Rotational inertia. Let's dig in. How difficult it is to speed up or slow down an object's rotation. There, it's that simple. There's nothing crazy about it. If I were to ask you to define mass, what would you say? Perhaps how much matter there is in an object, I hope. How difficult it is for the object's motion to change. Both of those are some good definitions for mass. When we define mass like we did in the second bullet, we give mass a new name, inertia. In rotation, there's a quantity called rotational inertia, or moment of inertia. This quantity puts a number to how difficult it is to change an object's rate of rotation. An object's rotational inertia, capital I, again, units kilograms times meters squared, depends on two things. How much mass the object has, that's the kilogram. More mass means more rotational inertia. And how far the mass is spread from the object's axis of rotation. The farther the mass is spread, the higher the rotational inertia. All right, so go right now. Get a cylinder of some kind, a rod or a pole or pen or a pencil, and then try spinning it as fast as you can so the axis is parallel to the cylinder's axis. That's this one right here. So if it's an eraser, you're spinning it with the eraser up or eraser down. Now try spinning it as fast as you can so the axis is perpendicular to the cylinder's axis, shown here. So it's rotating about its center of mass. It's easier to spin the cylinder on the left side because the cylinder's atoms are all closer to the axis of rotation. This means the cylinder just has less rotational inertia in this case. For a more complicated experiment, we've got two pulley wheels. The wheels themselves are identical, but each wheel has 4 gray masses attached, and these masses are identical. The only difference is the green wheel has the gray masses near the center, and the red wheel has them attached near the rim. When the masses are near the center, the green wheel has less rotational inertia, so the green wheel speeds up in its rotation more rapidly. So the green mass will reach the floor in less time. Is it the skinny twisting of the pencil, or are you laying it down and twisting it? Red wheel has a greater rotational inertia because its masses are near the rim. Put it on a ramp, same thing happens. Now the two wheels are set on the same incline. The red wheel, having greater rotational inertia, speeds up more gradually, while the green wheel's low rotational inertia allows it to speed up more rapidly. Now the two wheels initially have the same linear speed and angular speed as they roll on the flat surface. Because the red wheel has greater rotational inertia, the red wheel takes longer time to stop its rotation. Therefore, the red wheel will travel farther up the incline. The green wheel is easier to stop its rotation. It has lower rotational inertia, so the green wheel stops rotating after going a short distance up the incline. Maybe you can think about this kind of like momentum. If the mass is spread further from the center, then we would expect this to have a greater rotational inertia. Okay, but if we look at this, it just looks like the red one has more momentum. And in fact, we'll find out how momentum, angular momentum, and rotational inertia are related.